Uh, Hello, everyone. Today, we are going to talk about the use of inline data sources while querying Druid data. So let me walk you through the agenda. So first, I'll talk a little bit about myself and give you an introduction to Strivr. Then we'll talk about the Strivr stream processing platform, which writes the data to Druid, and then finally the use case. So to start with, uh, I am Amrita Deshmukh. I'm a senior software engineer at Strivr, and I'm part of the data platform team. I've been working at Strivr for 3 years now, and my team is responsible for building the various pipelines which perform real-time processing of data and ensure the easy and efficient storage, and finally, the retrieval of this processed information. Now, to give you a little background about Strivr, uh, basically, Strivr is an immersive learning platform. Immersive learning is a VR training methodology where you can train your workforce using a VR experience. It provides an end-to-end solution for immersive learning at scale, which is provisioning hardware, developing training to collect data, and then finally from these trainings, and then finally providing some valuable insights, which is where the data team plays an important role of processing and then making this data finally available to all the stakeholders, including the customers as well as the internal team. Now, to show you a bird's eye view of the Strivr stream processing platform, we collect the data, the basically the metrics and the training events from the VR headset, which is then uploaded to the cloud to GCS buckets. We have then a PubSub notification setup where we process these files in real time using data flow. Finally, once this data is processed and enriched with in some information, we write it to multiple sinks, and Druid is one of the major sinks from those. In order to write to Druid, we make use of PubSub streaming. So basically, all the events which are processed are written to PubSub stream, and then finally, we use a data flow pipeline to eventually write all of this data to Druid. Once this data has been written to Druid, we have a backend node service which runs on Kubernetes, which queries all of this data from Druid and then provides it to the front end customer facing portal. Now that we know a little bit about the Strivr's platform, let me talk about the use case. To give you a little background, we have something called as the business intelligence tags, which can be used by customers to further enrich the analytics. Now, BI tags are of multiple types, such as location tags, which can be used to append more information regarding the location of the VR device. For example, what city this device is assigned to. We also have something called as location tags, which can be used to append more information regarding the personnel who is training on the VR headset. The basic structure of the information that we store includes the customer's name, then the BI tag type, which could either be location or let's say login, and then the unique identifier for that particular BI tag type, and then finally BI tags, which are stored as in JSON format. Which have multiple tags, and where you can have multiple tags and values associated with it. Now, in this example, as you can see, we have a login ID for which we use BI tags to add additional information such as manager, and then as well as the designation of the employee. Now, to talk a little bit about the problem statement. With the ability to add BI tags to the device and the location data, we wanted to integrate this BI tag information into the Druid data source. Now, BI tags needed to be added to the Druid data source to enrich the data even further. Now, the BI tag information keeps on changing. It's not constant, and for example, a manager could change for an employee or his designation could change. So this information could not be added to the as a metadata to the event during ingestion time. We needed to add this information to the data during query time to guarantee that the latest value of the tags is used to enrich the analytics. Now, the BI tags could be used for different types of queries on the portal once it has been enriched into the Druid data. For example, once if BI tags are added, we could filter all the analytics based on the BI tags. Let's say I want to look at the analytics for basically all the employees for a particular location, or all the training data, or we could filter basis, let's say, all the employees for a particular manager. Say the second type of query could probably be a group by query, where analytics could be based on the BI tag value, as in you could group by the analytics basis a particular BI tag, which right now which would be like another column on the Druid data source. Finally, we could also be used for map queries. To give you a little background, we provide customers with the ability to export the Druid data as well. So with the help of, if the BI tags could be enriched into the Druid analytics, basically we could append the BI tags to each of the Druid analytics row, and then they could be shown in along with the existing analytics data. You could also have the BI tags data. So now, in order to enrich this BI tag along with the Druid analytics, at runtime, we looked at various approaches. So the first approach that we looked at was lookups. Now let me tell you why not lookups, why we did not end up using this feature. So lookups basically are a feature in Druid that allow you to join small amounts of dimension-like data at query time. So lookups are very lightweight, and they only support key value pairs, which can be inline. So basically, you could just have like a key and then just a value. So this inline data source is then passed to Druid with a query, or it's globally cached across all of these or all of your querying servers. Now, because lookups only support simple key value pairs, they weren't the best for our use case. As you saw, the BI tag structure was a little complex, as I showed earlier. So we weren't able to store the somewhat complex data structure that we have for BI tags. The value portion of our BI tag would be pretty complex because it would include the entire JSON for the BI tags along with the unique identifier and the tag type, etc. So the value portion of a single row in a lookup can also be an array. We even looked what if we pass it as an array, but the arrays cannot be translated back into columns that can be separately mapped or grouped or filtered. So it wasn't going to fit all of the use cases that we were looking at. Since the lookups are globally cached for efficient querying, the total data set that they recommend for lookups is very low, around say 100 KB. However, our BI tag data set across all of the customers was much bigger than that. So that is why we decided against lookups. So the second thing that we looked at was having an actual Druid data source in Druid itself. So now Druid basically and once you have the data source, you can just perform a join query between the analytics data source and the BI tag data source. So as we know, Druid does support join-like functionality between data sources, which is basically the direction that we were looking at, because the BI tag was a little bit of a complex data structure. So a join would give us all the functionality for grouping and filtering and mapping, as well as be pretty efficient. So that was the direction we were looking to pursue. However, with a regular data source, we'd have to deal with the overhead of ingestion. And also, BI tag is not a time series data. We could come up with some kind of versioning system, like where queries could always reference the newest version of the tags. But the way we store BI tags, we currently were not storing different versions. We were just storing the latest version because that is what we were interested in. So we would have to build a lot of infrastructure around the versioning to actually ingest the data into Druid. And also, as I mentioned, this would be some sort of a hacky solution because it was not a time series data. So another alternative that we also thought was we could replace the whole data store with the new tags as soon as they are uploaded. So every time someone uploads a new set of latest tags, we just delete the entire data source and regenerate it to get basically the join functionality that we needed. But at an basically, if the tags are being updated quite regularly, we'd be rewriting often, which basically isn't really a Druid use case, like, rewriting data again and again, rewriting the entire data source again and again. So to get the power of joining the data sources without the overhead of maintaining a regular data source, we came up with the final solution, which was inline data sources. So what are inline data sources? These data sources are passed as a part of the payload to Druid. And from a user standpoint, they behave exactly like a regular data stores during Druid query time. This means using inline data sources, we could accomplish the filtering, grouping, and mapping of the tags to the analytics without having to manage the complete data source. Now, here is a sample of the inline data source in a scan query, where the column for the tables are country and city. Now, so basically, this was the perfect solution for us because here we did not have to maintain the data source, and we could just pass our BI tag data source as a table inside the query itself. Now, there are a few limitations though of inline data sources. Specifically, they lack SQL query support, and they also have size restrictions. So our initial infrastructure where we used to query Druid was using basic SQL queries, and that was pretty helpful and also very easy to set up. But since inline data sources don't have SQL query support, we had to go back to using the native SQL queries. So what we did was we had like all of our queries translated from SQL to the native query language. And once we had that, we wrote helper functions that would take this base query and dynamically based on the type of functionality that you need, such as filtering or grouping or mapping component, you would input basically a query inside of the existing query, and also incorporate the inline data sources. Now, the second limitation that I mentioned was, since it's an inline data source, similar to lookups, you have size limitations. We tried to optimize to mitigate this risk. To start with, we filtered. So basically, whenever someone queries, in order to get the BI tags which needed to be added as an inline data source, we filtered the tags for that particular customer, so which immediately reduced the amount of data that we send. After that, if there are any additional filters that have been added basis the tag, we only queried for the rows of data which had that particular tag value. So that further reduced the number of tags that we were actually passing. Finally, if only some of the tags are needed, we only passed those tag values instead of the entire JSON that we have, like for multiple tags. So that is how we try to optimize. Even with these optimizations, there is a possibility that we can hit the limitation, the inline query limitation. The major query limitation is the subquery row limit, which says that an inline query cannot have more than 100,000 rows. So this, we know we can increase it, but there might be performance implications if memory is increased and is not increased accordingly on each of the historical process. So we have not faced this issue yet, but if we do, then that would be the next step, where we would increase the query limit and then subsequently also increase the memory limits on the historical processes. Now, finally, let me show you an example of the final query with the inline data source. So as you can see, this is a group by query where we are performing a join with an inline data source on basically a login ID type of BI tag, and it has just one tag added to it. But as I mentioned earlier, we have multiple tags. The customers don't have a limit of one, but they can add multiple tags to a particular location. So yeah, this is about inline data sources. Let me know if you have any questions. Finally, thank you so much for listening to me, and I'd love to connect. Please feel free to reach out. Thank you so much.